Good morning, everyone. This is Sachin Piske from Electrical Engineering Department, SND College of Engineering and Research Center. In the previous lecture, we discussed some components related to PLC or the components which are incorporated during the programming of the PLC. Now, today we are studying various types of sensor used in the PLC system. So, in that, first one is photoelectric sensor and switches. What is photoelectric sensor? Basically, this name indicates it depends on the light system or particular day-to-day life. Generally, we are going to use this photoelectric sensor and switches. This photoelectric sensor or photo eye is an equipment basically used to discover the distance or absence or presence of an object by using a light transmitter. What is transmitter exactly? Basically, the devices which can use to transmit a data, whether the data can be transmitted serially or parallelly. It may be a bit type or byte type, often infrared and a photoelectric receiver. They are largely used in industrial manufacturing. A retro rectify reflective arrangement place the transmitter and receiver at the same location and uses a reflector to bounce the light beam back from the transmitter to the receiver. An object is sensed when the beam is interrupted and fails to reach the receiver. So what is exactly the photoelectric sensor? The photoelectric sensor is a device that detects the difference in the light level received from the light source. The sensor is made up of a light source, an amplifier, a signal converter, and an output. There are basically three types of the photoelectric sensors available. These three major type of photoelectric sensor, that is through beam sensor, then retroreflective sensor and diffuse sensor. Each sensor has its own strength and can be used in a variety of ways. Let us see one by one. The first one is through beam sensor. In through beam sensing, also known as oppose mode, two separate devices are used to make or break a beam. A sensor houses the light emitter while the other houses the receiver. A through beam sensor detects object when an object interrupts the light beam between the two sensors. Through beam sensor can be used to detect very small objects, to detect the fill level inside container, to detect the spliced or overlapped material, to detect the precise location of the specified object, to detect the content of the container, and to detect the opaque object. The advantage of using a through beam sensor are that it is the most accurate type of sensor and it has the longest sensing range of the three. Through beam sensor are also the best choice when using them in a dirty environment. It's important to keep in mind that there will be at least two separate parts which need to be installed in order to make this device work correctly. A second sensor is retroreflective sensor. In retroreflective sensing, both the light source and the receiving devices are found in the same housing. The sensor works in tandem with the reflector. The light emitted from the sensor is aimed at the reflector, which is then sent back to the light receiving element. The sensor detects the presence of an object when the light path is interrupted. In addition to reflective sensing, there is a sensing, polarized retroreflective sensing feature a polarized optical block which reduces the response to hotspot glare from a shiny surface of the detected object. A retroreflective sensor can be used to detect the large object, to detect the object moving at high speed, to detect the reflective taps at high speed, and to sense a transparent or clear glass or plastic product. Retroreflective is the more affordable and only slightly less accurate option than through-beam sensor. When working with a clear or transparent product, retroreflective sensor are the best option. And another advantage is that the retroreflective sensor only need to be wired on one side while the through-beam sensor requires wiring on both the sides of the devices. The last sensor is a diffused sensor. In optical proximity sensing, also known as a diffuse sensor, and the light source and the receiver are housed in the same device. Diffuse sensor detects the object when the light beam emitted towards a target is reflected back to the sensor by the target. What makes the diffuse sensor a great automation option is that they are more compact and typical unit as all the components are in a single housing. Let us see some diffuse sensors can be used for which purposes. So basically this diffuse sensor can be used to detect the multiple objects on a common conveyor system, to detect the transient object, to detect the fill level inside the container, to detect the presence of a part, boxes and web materials, to detect the specific identifying features, to determine an object orientation, and to detect the unwanted condition for product inspection task. Diffuse sensors are easiest to install because everything is included in a single device and is a cost-effective sensing solution. The drawback to diffuse sensor are they are less accurate when used in a position detecting that through beam and retroreflective sensor, and they are not as effective on transient objects. In addition, these sensors can be the most affected by color, then texture, as the angle of incidence, target characteristics, and dirty environment. This proximity sensing diffuse arrangement is one in which the transmitted radiation must reflect off the object in order to reach the receiver. In this mode, an object is detected when the receiver sees the transmitted source rather than when it fails to see it. As in retroreflective sensor or diffuse sensor, emitters and receivers are located in the same housing, but the target acts as a reflector so that the detection of the light is reflected off through the disturbance object. The emitter basically sends out the beam of light that diffuse in all directions, filling a detection area. The target then enters the area and deflects the parts of the beam back to the receiver. Detector occurs and output is turned on or off when sufficient light falls on the receiver system. This is all about the transmission and receiver based sensor, and these photoelectric sensors are basically used to detect the distance or the defects of the difference in the light level receiver at the terms of the receiver or terms of the transmission of the system. In major cases, PLC uses this photoelectric sensor for transmission of the data, or whenever the electric supply is transmitted from source to load. Generally, such type of sensors are used in the system. To implement these sensors in particular programming language, this it is very easy and the cost effective is also very less. So such type of sensors are used in the system very easily. Thank you.